All right, Algebra 2, here we go. Moving on, arithmetic series. Okay, we did an arithmetic sequence. Now we're looking at the series. What is an arithmetic series? Okay, a series is the sum of the terms of a sequence. So when we had that sequence and we had like, for example, 2, 4, 6, 8, blah, blah, blah. It's arithmetic because it goes up by a common 2. You're adding 2 each time. So that makes it arithmetic. And it's a series now because we're adding them. Okay? So whereas the sequence, now the series, we add them together. And if you're trying to find the sum of the arithmetic series, and what we call a finite, because it could go on forever, but if we give it an ending, like an a to the nth, there's a final term, okay? You can find that sum without having to actually add them all up. It would just be the sum of n terms would be n over 2 times the first one plus the second one. Okay, so n over 2 times the sum of the first and the second, or first and the last term. So what would it look like if you had 2 plus 4 plus 6 plus dot 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 plus 100? Okay, how would you find that sum? Well, first off, we can see it's arithmetic because it goes up 2 each time. So that's our D. Okay, when you think back arithmetic. Now, how many terms are there? Well, you're going up by evens. It's like 100 divided by 2. There's 50 terms. I'll show you another way to do it when it gets, that's pretty straightforward there. But so to find the sum of the first 50 terms, since n is 50, you put 50 in for n. 50 over 2 is 25. The first and the last terms added together is 102. 25 times that, 2,550. If you added up that whole series, that's what you would get. Okay? Arithmetic series. There's the formula for it. Alright, let's take a look at another example. Alright, find the sum of 7, 11, 15, dot, 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 all the way to 223. Okay? We can see it's arithmetic, and we're going up by 4 each time, so that's our D. Our problem is how many of them are there? What's n? Okay? Well, to find n, we want to use the explicit formula, which, remember, explicit formula, you put in the first term in there, and you're using the n minus 1 times d. The recursive, you needed to know the one before it, which we can't use here. And we want to find n. So let's just plug everything we know. There's our explicit formula for arithmetic. We know the last term, the nth term, is 223. We know the first term is 7. We don't know our n, but we know our d is 4. We're going up by 4 each time. So I'm going to distribute the 4 out, so I get 4n minus 4 plus that 7. I get my 4n, 7 minus 4 is 3. Subtract the 3 over and divide by 4. There's 55 terms. Okay? So that's going to be our n. So to find the sum of the 55 terms, it's 55 over 2 times the first one plus the second one. You get 22.5 times 230. 6,325 would be the sum of those. Okay? Another way of looking at these is using a summation symbol. This is sigma. Okay, the summation series. And what we call the limits are right here. What terms we want to add. You want to add the first 5 terms, then it's going to be from 1 to 5. You want to add up the 5th term to the 8th term, it'd be 5 to 8. Okay, that's the limits on which terms of that sequence that you want to add. This formula right here is going to be the explicit formula for that particular series. Okay? And for us here, if it was n squared, then if you want to find the sum of the first 5 terms of n squared, then in sigma, summation, you plug in 1 first and you get 1 squared, plus plug in 2 all the way up to 5. Okay? So you've covered from 1 to 5. There's the first 5 terms using this explicit formula. Whatever n is each time you plugged it in, and that's what we did. Okay? And you could add them up and figure it out. Okay, here that's good enough right here. Just wanted to show it. Let's take a look at a last one here. Let's say we want to write 7, 11, 15 plus, but all the way up to 207 in summation form. Okay? There's our sigma we're going to do. We got to find, so that's our summation. That's what we're looking for. We need the explicit formula right here. Where did that 4n plus 3 come from? Well, there's my explicit formula. I plugged in my final term, my nth term, 207. There's my first term, n minus 1 because we don't know n. We do know we're going up by 4. It's almost the same one we just did. Okay. When I distribute here, I get 7 plus 4n minus 4. 7 minus 4 is 3. There's my explicit formula right there. Okay. I can finish solving this down, and I find that n is 51. So if I want to find the sum of all that, or write it in summation form, I'm going to go from 1 to the 51st term, which we just showed is 207. And then in here is the explicit formula. It's this part right here, okay, which turned out to be 4n plus 3 when we brought it down to it. Okay, simplified it. That's the word I was looking for. So there it is in summation form. If we want to add up the first 51 terms, and you can see when you plug in 1 here, you get 4 plus 3, there's your 7. Plug in 2, 8 plus 3 is 11. So that sum of that would take us all the way up to, plug in 51, 4 times 51 is 204 plus 3 is 207. So that's another way of writing it right there. Explicit formula right here, okay? Which is what we get on the right hand side here before we solve for n. Alright, so arithmetic series, it's the sum of the arithmetic sequence. We've got a formula for it, s of n equals n over 2 times the sum of the first and last terms. And we can look at writing it in a summation form. Okay? Hopefully that's been helpful. We'll look at some more examples of this tomorrow. See you then. Bye.